Hello, in today's lesson we'll be discussing databases and specifically how to work with SQL Server 2005 Express Edition databases. We'll begin by looking at what a database is, what they're used for and how they're structured. A database is a structured repository for data. So basically, information is saved in a database, you read the information from the database, you update it, and you can also delete it. The information in a database is organized in a way so that it can be easily retrieved, sorted and grouped and related to other data, thus enabling it to analyze information in various ways. Say if you have a business and you want to attract customers, a text file using Notepad is one way of storing customer names. But then the list of names eventually becomes so long that it's difficult to manage. You'll find yourself scrolling through it looking for the customer you need to contact. The other way to store customer names is in an Excel spreadsheet. This may work initially, however, if you want to view all the purchases in the month of April, for example, for your top 10 customers, whilst it's possible, the spreadsheet may look a little busy, so to speak. It's much simpler to use Relational Database Management System, or RDBMS, like SQL Server. There are many benefits in using a real database compared to text files or spreadsheets. SQL Server 2005 Express Edition allows you to really harness the power in even the most basic applications. RDBMS, or Relational Database Management System, is an approach to designing a database which is somewhat similar to writing object-oriented code, although at the same time they do have very different techniques and goals. In relational database theory, you organize your data in the tables that are related with other tables. There may be a table just for customer names and another table for order information. You could have one table where you put both things in, the customer names and order information. But then it would become very confusing, as there could be instances where a customer ordered twice and called himself, say, Bill in the first order and then William on the second order. Or if the customer moved house, for example, you really couldn't be sure whether both orders were faxed from the same customer. So it would be wiser to separate this information into different tables. Now let's look more at database objects and, firstly, tables. The table is the foundational database object. A table consists of columns and rows. A single column and a single row is usually known as a field data. The columns define the type of data that will be stored in the table. The rows, or records as they are also known, define the actual data. A basic customer table may have columns containing first name, last name, address, date, customer since date, credit limit, etc. Now, we need to find more information about each column so we can maintain data integrity. We need to find the type of data that's going to be stored in the column. If it's a string data, we'd have to define the maximum number of characters in the string. We also need to define whether we could save a certain record if it contains fields of information with null data. Data integrity is one of the major things that a relational database system will help you maintain. So we might not want someone to be able to add data that sets our credit limit field to $2,000 spelled out in letters. We'd want it written out numerically, a number that represents currency. In this case, we'd use the currency data type. This will prevent anyone from spelling out $2,000 because we can't add the words 2,000 to a currency value of 1,500 or so. This is also in the case of customer since field. We define that as a date data type, so only date values should be allowed there, and state should only allow 2 characters like NY for New York. It could be that we want to allow a record to be saved to the database if it doesn't include an address. However, we wouldn't want a record where the name is missing. So we could make certain fields like address, state and zip to be null fields, which means these fields do not have to be supplied in order for the record of data to be saved successfully in the database. Now, if the name is missing, the database will not allow that data to be saved in the database. It's basically a way of maintaining the integrity of the data in the database. Data integrity makes sure that the data that's in the database is correct and thus useful for any applications that might use it. We're going to add one last column called Customer ID. This type of column is referred to as the primary key. This key differentiates two records that may have the same name. So there may be two records with the exact same information, such as the same name and the same address. You'd need one field extra to differentiate the rows. Normally, this would be a numeric field. A special property of that column could be set called identity. Each time data is added to the database, this would automatically put the record in number order. It will then use that number field of information for each record of data as its primary key. So that is what differentiates from the other records in the database. Another thing a primary key is used for is to relate two tables together. So now we'll define an order table. So just for our example, we have 4 columns: order ID, order date, order amount, and payment type. Now what we've done is omitted the information that allows us to determine who actually created this order. So what we need to do is relate a row from this table back to a row in our customer table. To do this, we need to use a foreign key. So we need to add one more column of information called Customer ID. Incidentally, we named this field the same name as in the customer table. We can actually name it whatever we want, but for the purpose of learning and understanding, it's easier to name them exactly the same. So by creating an order record and including the customer ID, it's simple for us to track any order back to the customer that created the order. We can also easily backtrack all the orders back to the customer that created them, and tally how much the customer spent with our company and more. So to recap, there's a primary key in the customer table called Customer ID. There's also another key in another field in the order table, which is the foreign key. So now we can relate these two tables together. Also, the primary key and the foreign key can be related together to make a relationship between the two tables. However, there is a potential problem from a database perspective. If we deleted a customer in the customer table, then all the orders that were placed by this customer would be orphaned. This means that we wouldn't know who placed those orders, and that would be a big problem. So we need to create a special object in the database called a constraint. This is called a foreign key constraint between the order table and the customer table. Once this is done, it would be impossible to delete a customer before deleting all the associated orders first. The database won't allow it, because if it did, it would violate the integrity of the data in the database. Orphaned rows are not allowed. So I hope the idea of relational database made some sense to you there. Relational databases help keep data structured and easily managed. They reduce redundant data by separating the exact same data and putting them in their own tables. They also help to maintain the integrity of the data. What we'll do now is use what we've learnt to create a SQL Server 2005 database. We'll add tables and fields and relations to the database, then add some data to it. I've created a new project called Lesson 8. There are actually many ways to create a new SQL Server Express 2005 database, but for our example, I'll use a more project-based approach. So right-click on My Project and select Add, New Item, and from the Install Template section, I'll select a SQL database. And then change the name of the database to lesson8.mdf and select Add. You'll get this data source configuration wizard, which comes up by default. Just cancel that. Then double-click this file within the Solution Explorer so that I can open up the Database Explorer with my database already loaded in. Now there are some files underneath the lesson8.mdf file, which is under the Data Connections node. We want to focus on our tables. The database contains no tables by default. So I'll right-click and select Add New Table. Now we have a designer surface where we can create a new table. Let's just create two tables that we can use later within our RSS Reader application. We'll create a folder table first. So in the box next to column name, create a folder ID, which we'll use as my primary key for this table. For the data type, place the cursor in the data type column and use the combo box and find the integer data type. Then deselect allow nulls because I don't want this field to allow any nulls. Remember, when we are creating a primary key, we're going to select a special property of this column called the identity property, which will automatically number each record of data that's added to this table. So scroll down this column properties tab and find the identity specification. Double-click it to turn on the automatic numbering. Then in the next row, create a second column called folder name. And it defaults to nChartN. What we'll do is place text information and allow up to 50 characters and allow it to be nullable. One more thing which needs to be done is tell the database what we intend to use this column for. So select the button on the toolbar and set the primary key. You'll see a key that's been added next to the folder ID column. Select the Save button on the toolbar, and then it asks me to choose a name for my table. I'll name this table Folder and click OK. So now a new table called Folder has been created in the Database Explorer. I can also see all the columns that are related to this folder: folder ID, folder name. When I select either of these columns, we can view properties about that column on the right-hand side of the property window. They're greyed out, so we can't change anything, but we can see some information about the folder ID, etc. Let's close this and return to tables and create a second table. This table will hold channels. Make this integer, turn off nulls, and set this as my primary key. Now, I remember I didn't turn on the identity chart. So let's return to my identity property and select yes. Channel needed URL. Use nvarchar and change it from 50 to 250. This will allow me to put 250 characters of string data in this column. I don't want it to accept any rows, but I will allow it to be null. Lastly, I'll create a foreign key back to the folder table because we want a relationship between the folder table and channel table. So select Save, we'll name this channel and select OK. So we have a second table with 4 columns defined. Now we want to create a relationship between these two tables. There are many ways of creating these relationships, so we're going to take the visual approach for this first time. We'll start by creating a database diagram. So in Database Explorer, select Database Diagrams and right-click and select Add New Diagram. It'll say that it doesn't have one more of the database objects needed to use database diagrams. Do you wish to create them? Select Yes. It'll then ask for the tables that you want to add to this diagram. We want to add both. So select the Add button once, then a second time, and click the Close button. Now you have a visual view of the two tables on my database. To create a relationship between these two tables, you have to put your cursor over the first one's grey area and hold down and drop it in its corresponding primary key in the other table. Then some dialog boxes come up. The primary key table on the left-hand side is the folder, and the primary key itself is the folder ID. It gave it a default name of fk_channel_folder. So we'll click OK and then OK again and save the whole project, including the tables. We'll call it diagrams. I've expanded the data connections one more time to get back. So there's my diagram, my tables, and there's a relationship between those two tables. So now we need to start adding data to our table. We'll begin with a folder and right-click it and select Show Table Data. In the main area, a type of grid will open up. There's columns at the top, and we'll start typing in data for the rows. So we'll call this First Folder and then use my Tab key on my keyboard. You'll see it put a 1 automatically in the folder ID for my first row of data. Here I'll type Second Folder. When I'm making a modification to a row, I get a pencil on the left-hand side which appears as if it's editing, which is basically what we're doing. We're making a modification to the row. So here we've added 3 rows of data to our database. We can use the navigation buttons to move to the first row. The arrow cursor will go to the first row of data, and I can use the next and previous buttons, which will let me go one at a time. I can move to the last row of data and select Move to a new row. It automatically puts me in a position where I can add an extra folder. If I type in a number and hit Enter, it puts me in that row of data in my database. Now if I want to make a small amendment, say to the folder name, I just need to go to that row, type it in, and then click Elsewhere off that row by using the Tab key, and the amendment will be saved. To delete a row of data, press Select on the right side and click the Delete button on my keyboard. It'll ask if you want to permanently delete this, as you won't be able to undo it. Select Yes. So folder ID 3 has been deleted. Only first, second and fourth remain. So that's how to navigate through a table of data and create and change and delete the data. Now let's go to Channel. The same process, show table data and start adding some data. First title, first URL. We have to give it a folder ID. We'll try to use the Tab key on the keyboard. It says, no rows were updated, the data in row 1 was not committed. Basically, it's not possible to insert the value null into the current folder ID. So we can only use either folder ID 1, 2 or 4, as these 3 folder IDs are the only ones in our folder table. We'll use folder ID 2 and click the Tab button again. This time it works. Now say I wanted to change this to a number that's not in our folder table, like 7. There is no folder ID of 7 in our folder table. When I click the table, it says that the data in row 1 was not committed. This means that the update statement conflicted with the foreign key constraint FK channel folder. Again, this ensures data integrity. It's not possible to create a channel as there's no associated folder ID of 7. We can only use folder ID that's associated, like 4, and it's successfully updated. We'll do the second title, second URL, and folder ID 1, then third title, third URL, and folder ID 2. So we'll return to our folder table and try to delete this fourth folder. So select the delete button on the keyboard and it says you're about to delete one row. Click yes to permanently delete the row. You won't be able to undo the changes. Select yes. But then an error message appears saying, delete statement conflicted with the reference constraint FK channel folder. So, to maintain data integrity, the database will not allow us to delete a row from the folder that would potentially create orphan rows in my channel table. In the next few lessons, we'll look at how to enter and retrieve the data to the database using a Windows applications. This is when it'll all start falling into place and making more sense. So for now, thanks for watching, and I'll see you again in the next lesson. Bye bye.